All right. For the homework tonight, we're starting off with some graphs. So the first one we're doing is number 21. The original f of x is 3/5 to the x power. And we have to describe the transformations and then sketch the graphs for g of x. So, and I didn't sketch the original f of x graph just because that gets too cluttered. So what I am going to do is on f's graph, list out the nice points. So when you plug in 0, any number to the 0 power is 1. When you plug in 1, 3/5 to the first is 3/5. Might be a good idea to plug in -1. That is the reciprocal of this number, 5/3. I like to have 3 points. You need a minimum of 2. And then remember there's this horizontal asymptote of y equals 0. So then what's going to happen to those points? So the +4 is left 4, and the negative out in front is an x-axis reflection. I guess I'm supposed to list this. Okay, whatever. And so remember, do the reflection first. So that means that x-axis reflection means every y gets multiplied by -1. And then after you reflect, you'll go left 4. So these points are going to become 0, -1, 1, -3/5, and -1, -5/3. When you multiply y equals 0 times -1, you still have y equals 0. And then you're going to go left 4. So I like to draw in the horizontal asymptote first. So it's still sitting at y equals 0. And then we're going to be at 0, -1, but remember to go left 1, 2, 3, 4. 1, -3/5, and then 1, 2, 3, 4. And then -1, -1 1/3, and then 1, 2, 3, 4. So having 2 points gets a little confusing when they're not very far apart like this. So that's why I like having this third one in here. I can see more clearly that, this is curving away from the line, and it should be getting closer to the horizontal asymptote on the right. For the second graph, same idea. So the original is 0.4 to the x. So nice points would be 0, 1. When you plug in 1, you get 0.4 or 4/10. When you plug in -1, what's the reciprocal of 0.4? So remember, 0.4 is 4/10, which is 2/5. So when you raise 2/5 to the -1 power, you get 5/2, or 2.5. And again, it's got this y equals 0 horizontal asymptote. Okay, so what's happening to this graph? There's no stretching or reflecting. The -2 is right 2, and the -3 is down 3. So I'm not going to write out what these new points would be, but if I shift the horizontal asymptote, because that's what I always start with, shift it right 2, that doesn't change anything, but shift it down 3, and now it's at y equals -3. So a vertical shift will affect the horizontal asymptote. All right, so 0, 1 gets moved to the right 2 units. Oh, and down 3. Oops. So try that again. 0, 1 goes right 2 and down 1, 2, 3. 1.4, and then that goes right 2 and down 1, 2, 3. All right, and then -1, 2.5 goes right 2 and down 1, 2, 3. Something like this. So notice I'm not making you find x-intercepts, y-intercepts, because, we could, but that would still just be plugging in 0 for x. But I'm still just going off of have your 2 nice points at least and maybe a third one. All right, nice points on this one are 0, 1, 1, 10. And if you plug in -1, the reciprocal of 10 is 1/10. Y equals 0. What's happening here? This is one of those special case ones. Remember, if you have a y-axis reflection and a horizontal shift, you've got to factor the negative out to see which way the shift is really going. So this is a y-axis reflection, which means every x will get divided by -1, and y will stay the same. And then after that, you're going to shift to the right 3 instead of what looked like left originally. Okay, so does any of that affect the y equals 0? No, because shifting a horizontal line to the right doesn't change anything. and there's no x to multiply by a negative. So that's still going to be sitting at 0. And then 0, 1 is going to become, or it's going to stay 0, 1. 110 will become negative 1, 10. Negative 1, 1/10 will become positive 1, 1/10. That's just me doing the y-axis reflection part. And then I'll shift all of those right 3. So 0, 1, and then 1, 2, 3. Negative 1, 10, and then 1, 2, 3. And 1, 1/10, and then 1, 2, 3. So this is like a really steep looking curve like that. The higher the base number, the steeper the curve is, the faster it grows or the faster it decays, depending on what it is. All right, last graph here. So nice numbers are 0, 1, 1, 1/2, and then when you plug in negative 1, you would get 2. We have a horizontal asymptote of y equals 0. And then this has been factored out for us, so that's nice. So this is still a y-axis reflection, and that means negative x, y. And then we're also going to go left 4. So let's write down the negative x, y points. And you don't have to write these down. My brain cannot keep all that information straight, so I like to just do some of the work here. So I've multiplied all the x's by negative 1. The horizontal asymptote has not been shifted vertically, so it's still sitting at y equals 0. Okay, and then 0, 1, and we're going to go left 1, 2, 3, 4. Negative 1, 1/2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. You can also do more than 3 points. If your points are falling in a weird way or something kind of went wrong, you might have miscalculated something. So plug in some more points and see what's falling in line. Okay, now we're skipping to the geometric sequence part. So in our textbook, this is chapter 8, just in case you were curious about that. So find a formula for the nth term or the general term of a geometric sequence, then find the indicated term of the sequence. So we have 3, 36, 432. We're supposed to find the 7th term. So to find the nth term, remember we have this formula. The nth term could equal, because we have the first term, the second term, and the third term. So because we have the first term, I'm going to say my formula is A1 times the common ratio raised to the n minus 1 power. I need to find the common ratio first. So it should be r is equal to 36 divided by 3, which should also equal 432 divided by 36. And you can use a calculator for this. 36 divided by 3 is 12. Okay, I know that. But I want to check the other one, 432 divided by 36. They're telling me this is geometric, so it should come out the same. R is 12. So our nth formula is just the first term, which is 3, times 12 to the n minus 1 power. That's the nth term or the general term. And then you can use that to find the 7th term. So if I want to find the 7th term, it should be 3 times 12 to the 7 minus 1 power, which is 3 times 12 to the 6th. So 3 times 12 to the 6th power is 895. I'm going to write this down. 895. 7952. So, oops, put my commas in the right spot. Sorry. There we go. 8,957,952. Yes, I wrote that right. Okay, so that's our 7th term. Now, the 7th term is not too far off, so you could also keep track and be like, okay, multiply this by 12, multiply that by 12, multiply that by 12. But, if you have to find the 22nd term, you might just want to use the formula. All right, so again, let's say it's a sub n times the first term, or equals the first term times the common ratio to the n minus 1 power. So what is the common ratio? It's 8 divided by 4, which should also be 16 divided by 8. I don't need a calculator for this one. That's 2. The first term I can see in the sequence is 4. So this is equal to 4 times 2 to the n minus 1. All right, so now let's find the 22nd. That's my general term. Now let's find the 22nd term. It's 4 times 2 to the 22 minus 1, to the 21st power. Again, you would have a calculator for this. I'm not going to make you do 2 to the 21st. So that's 8,388,000. 608. All right. Now, what if they don't give us the first term? So take a look at the next section. This says we're doing 44 and 46. Find the missing term of the geometric sequence. So they don't say find the general term, although you'll need that. And they don't give you consecutive terms, so you can't just quickly divide these and find R. They give me A3 and A1 and A3, and I need to find A8. So remember, in our notes, if we're not given the first term, there's a more general formula that says the nth term can be any kth term, any k term here, times the common ratio, and then it's just raised to the n minus k power. So if k is 1, this is the same formula we just used, but k can be anything. N should be bigger than k, by the way. You're always trying to get to the next term. So what do we have here? We have the third term, and that is equal to the first term in this case, times r to the 3 minus 1. So let's fill in the numbers that we have. The third term is 45 over 4. That's equal to the first term, which is 5. We don't know r, but, I don't need parentheses here. R is just squared to the 3 minus 1 power. Divide by 5, which really means multiply by 1/5. 45 divided by 5 is 9 over 4. So r squared is 9 over 4. Now in our notes, we said our example like this was like assume r is positive or assume all the terms are positive. But here it doesn't say that, so we can get plus or minus. So when I square root, I'm going to get plus or minus 3 over 2 for r. Okay, and let's just see kind of what happens. We're finding the 8th term here. So, all right, so the 8th term could equal, now you can choose, use the first term or the third term. I'm going to use the first term because it doesn't have a fraction. So I'm going to say it's the first term times my plus or minus 3 over 2 to the 8 minus 1 power. Right, so the 8th term is 5 times plus or minus 3 over 2 to the 7th power. Now, you're raising something to an odd power, so it does matter if it's positive or negative. I'm going to get 2 different answers. So A8 is going to be plus or minus whatever I get when I multiply this out. So let me split this so I'm not covering this up. So 5 times 3 halves to the 7th power. If you want to confirm this, if I made this negative, I still see how it's the same answer, just plus or minus. So I'm going to write to the nearest, well, let's see. Can we do a fraction? Oh, we can. So I can change that to a fraction. That was math fraction, by the way. So I can either round this to 3 places, or I'm going to use the fraction. So 10,935 over 128. Or that was about equal to plus or minus 85.430. Just make sure you round correctly. Okay, what about 46? So here we're not given the first term, we're given the second and the fifth, and we need to find the 6th. So I like to just use my formula, set it up first with just the generic setup. So the higher term goes on the right here so that you're not getting a negative here. So a sub 5 equals a sub 2 to the r times r to the 5 minus 2. So a sub 5 is 64 over 27. A sub 2 is negative 8. R is to the 3rd power. So get rid of the negative 8 first. So divide by negative 8 or multiply by negative 1/8, whatever. That gives you negative 8 over 27 equals r cubed. Now, when you cube root, remember when you odd root an equation, there's no plus or minus. The cube root of negative 8 is negative 2, so there's no I here. Cube root of 27 is 3. So r is negative 2/3. So now I need to find the 6th term. So again, I can choose to use, it is just the 5th term times r, so I could do that. or I could do my second term times negative 2/3 to the 6 minus 2. You could do it either way. I just, I don't know. I like that the second term has a whole number, although it is easier if you have the fifth term and you're finding the sixth term, just multiply that by r. I'll do it both ways. We'll get the same answer. All right, so this is negative 8 times negative 2/3 raised to the fourth power. Oops, I did something wrong here. Not 2/33. Change that to a fraction. Negative 121 over 81. Let's check if it was just a6 also just equals a5 times negative 2/3 to the first power, right? So you could also say, just confirm this, 64 over 27 times negative 2/3. Yeah, 64 times 2 is negative 121. 27 times 3 is 81. So that is the correct answer. All right, so I'm going to erase that so it's not on my key, though. Okay, that finishes this homework. Please come into office hours during Chapter 3 if you're having trouble with any of this.